All right, the purpose of this video is to kind of walk through lab one, which is your plan and spec reading. So you're going to be taking a look at the MEP plan and spec reading PowerPoint, which you have access to. I'm going to walk through that for a bit. It's a pretty long PowerPoint, but I'll try to break it down and whip through as much as I can to help guide you. The next step I'll talk about, once we're done with this, I'll talk about some of these lab resources, how they might come into play. They're just good general resources anyways for understanding, how to read symbols, how to look through, different examples of diagrams, duct drawings, wiring drawings, one line, stuff like that. So different URLs that you can look through, a couple files, and then we'll get into the assignment, like I said. So I don't take up so much of your time. Right off the bat here, here is the MEP plan and spec reading PowerPoint. So we're going to talk about these items: the importance of quantitative versus qualitative information, different formatting for plan sets and for specs, and then a couple plumbing specific, mechanical specific, and electrical specific formats or items that you need to be aware of, especially as a manager. Also note there are different systems as well. I'm not going to go into all these, just to understand that, for fire protection, for AV, all those different things, they have their own sets of plans, they have their own nuances. A lot of them are done by third-party consultants. So you'll often see like maybe a little bit different formatting on those plans. Your job primarily though is to coordinate those, make sure that you're working with, say for instance, like your communications, working with your electrical to make sure that you're getting the proper information and coordinating everything accurately. So going through quantitative and qualitative information. So qualitative refers to measurements or quantities, right? So the quantitative information that you get on your sets of plans are numbers of doors, plumbing fixtures, all that kind of stuff. We're also talking about lengths, where we have distances, areas, all that kind of information. So the qualitative data then that you would be getting in your contract documents would refer to subject descriptors or qualities, right? So instead of having dimensions or distances, what we're talking about is material types, what the quality of material is that we're dealing with, what the quality of the equipment is that we're dealing with, right? The requirements, what kind of horsepower they need to operate at, how they have to be installed, all that kind of stuff. What kind of colors and finishes and everything that we were dealing with. Why they are important? Because you find this information in different parts of your plans and specs. When it comes to quantitative information, you generally find those in your plans. When it comes to qualitative, you generally find those in your specs. However, there is a lot of times that you will find qualitative info in your plans. One of the biggest places that you'll be doing that or seeing that is in your schedules. So primarily your MEP equipment, all that kind of stuff, you'll be finding a lot of qualitative information in your schedules. So it's important to note that if it's not really something in your plans that you're seeing, or sorry, in your specs that you're seeing your qualitative info, it's probably in a schedule. Sometimes it's in both. That's where we also run into some problems with coordination challenges to see, or if the information in both those documents are not accurate with each other. You'll also sometimes find qualitative information in keynotes or details as well. Okay, moving on to plan set formatting. So this is all generic information because every project's a little bit different. So I just want to reiterate the importance of when you get a new set of plans and specs on a project, it's important to read through them, get a good feel of what the table of contents is so you know how to get the information quickly, because you might have literally thousands of documents. I've been on projects where we've had entire plan set rooms where, it's 1,000 or more square feet because you're working on an $800 million hospital. Again, there's no universal designations or standards for the sets. It's up to the architects, engineers, whoever's creating the documents. So that's why it's important to look through how do they like to designate the drawings? How do they label them? How do they number them? Because if you don't know that, then you're going to be spending a lot of time bouncing back and forth trying to find information. So the generic sets that you would be dealing with would include these, right? So index, any kind of general information. A lot of times you might have code information or stuff like that on there. Demo, civil, structural, and so on and so forth. Again, it's up to the architect how they want to do it. A lot of times what you'll see is plumbing and fire suppression still get lumped under the mechanical designation because that's how they used to be, and they're still all mechanical pieces of equipment. But specs and the CSI divisions have now separated them. A lot of architects will keep them separate. A lot of architects will lump them all as one. So again, you might see it, you might not. It's up to the architect. It's based on the project. Okay, so once we've learned all this information, how your set of plans is set up as far as the designations, right? It's important then to understand how the plan sheets are set up. So are we numbering and labeling them as 000s, or are we 0.0s or 0-0s? Because they all indicate something different. Again, it's up to the architect how they like to do it. So when we say 000, something like this, we're talking 001, 100s, right, 200s, 300s, and so on. The equivalent of a 000 would be a 0.0. So like an A101, for instance, would be very similar to like an A1.1, right, or a A1-1. So just know that that's how an architect will generally set up your plans. All right, so moving on here, we got additional information on sheet type. So usually anything that's sub 100, so like a 001, for instance, is some sort of general information type plan, right? So maybe code compliance, maybe design standards, maybe indexes, stuff like that within your architectural plans, because it's an A designation. So if using the 0.0 system, would be an A0.1, would be a sub 100. So 100s are generally some sort of an existing condition. Again, not standard, but generally speaking, if you're using this designation style, it's a 100 would be existing condition. If you have a new building, sometimes you might not have a 100 within that set. Sometimes that 100 would then be maybe your new work section. But if there's demolition involved, you're probably dealing with a 100 set as a as existing condition for demolition. Okay, the other thing as we're moving forward here, oops, example of this, right? So M101 may be a mechanical demolition plan on the first floor. So a lot of times this is indicating, what type of drawing we're dealing with. So in this case, it would be a demolition drawing, and this would indicate what floor we're on or what area or something like that. So for this example, it would be first floor of mechanical demolition. Now moving further, 200s are generally your new work plans, right? So some sort of floor plan. So a P203, for instance, or a P2.3 in the equivalent, maybe a plumbing new work plan for the third floor. So plumbing plan, 200s indicate new work floor plans, 3 indicates floor. So third floor. So after 200, it starts to become even more heavily with AE preference, right? So architectural versus structural versus civil versus mechanical, all those different things. Since there's different requirements for each of them, they will have their own specific drawing types that are required. Also important to note, when you're dealing with work activities, any black lines that you have indicate work activities that you are performing. Any gray lines indicate items that you are not touching. So especially when you're talking about demolition plans. So if you're on a demolition plan and you have a black line, that generally indicates you're taking something out. If it's on a new work plan and you see black line, you're generally putting something in, right? On the flip side, if it's a demolition plan and you see gray lines, it's probably something you're not touching and you're leaving in place. But if it's on a new work plan and you're taking a look at and you see a gray line, it's probably not something that you're touching. So it's an existing building. Okay, using some architectural examples here. I'm going to kind of skip through these. I'll let you guys read through them, give some examples on just what a sheet index might look like as well. Let you guys look at those because I want to get into some other examples. Okay, I mentioned how plumbing and mechanical used to all be as one. It was division 15. But now that we've moved to 50 divisions, we no longer have 16 divisions. Plumbing has its own, so you're in the 22s. I'm going to skip through some of this stuff too, just showing some more of the designations, but this is just indicating that you also might have M's as well, which I already noted. Okay, and then some sheet types for mechanical. right? So again, we're dealing with forced air, hydronic, in-floor, different types of sheets you might be able to see. But again, I'll let you guys go through all this stuff on your own so I can get through and get to the assignment a little quicker. And the same goes for electrical. Okay, so spec formatting, another big thing to understand if you aren't quite aware of how specs are formatted. Again, we have 50 divisions in the new master spec. You might still be dealing with projects that have 16, which is the old spec where we have a lot of things combined. I personally like the 50 a lot more because I can find information a lot quicker instead of looking through, say, division 15, for instance, to try to find everything I'm looking for in my mechanicals. The table of contents is a really big deal. It's also important to know that if you're looking at a table of contents and you see, a spec section that's got some piece of equipment, it's important to note that that's an item that's going to be part of your project. So we don't just add things that are existing conditions into the specs, and we normally add those type of things into plans for coordination purposes. Bluebeam is a good tool. A lot of you will either have used it or will have to use it throughout the program here, so you can understand, there's a good way to set up links. You can jump to a lot of information very quickly. But also knowing information and knowing how those specs are set up is a really big deal. So we're going to get into the parts of the spec. Your specs are broken down into 3 parts. There's always a general, there's always a products, and there's always an execution section. The general section refers to, it's, again, and I'm repeating myself all the time, but it's up to the architect how they like to actually lay everything out, but understanding that you're going to summarize generally what this section includes, any kind of references as necessary if needed, what type of submittals are required for that, what are the qualifications that are probably required in order to meet those. So for things like MEPs, you're going to normally have a lot of qualifications, what the warranties are. These different items might be part of your Part 1 general sections. Part 2 is where we actually figure out what the products are that we're dealing with. So each product that's part of this spec will include all the different detailed information of, what the product is, what general standards they've met, as far as like testing, if there's like testing requirements and stuff like that, like ASTM standards, you're going to see those all the time, or NFPA or NEC or whatever those might be that say that this product meets those requirements, and that's what we need for our project. Within each product, right, we might have several subsections, so we can take a look through and see what all the components are that make up that one product. So like an air handler might have a bunch of different subsections that indicate how each of those items have to either operate or what are the requirements for those. And then part 3 is execution. So things like examining, how do we have to actually install the items after we examine, right? What kind of field service might be a requirement? What kind of startup and testing requirements we would have? The cleaning is often found here, and there may be even specific warranties that are listed in this section. So even in part 1 where they're generally listed, I've still many times seen specific warranties on different products in the execution piece, and how you kind of have to implement those warranties or track those warranties. So the next couple sections just deal with a little bit more plumbing, mechanical, and electrical related items. So remember, when it comes to plumbing drawings in particular, it's important to note, I kind of break it down into 4 categories. Now, we have domestic water, sanitary sewer, and storm sewer. Gas is one that I always throw in the plumbing because, generally speaking, I've seen it in the Division 22 more often than anywhere other place. It's generally products that would be the same as what you'd be doing for water piping, or similar to water piping. A lot of times you have the same certifications required. But I have also seen gas thrown in Division 23. I've also seen it thrown on mechanical drawings. So you have to know how your plans are set up. This is generally how I've seen it, and this is how I've kind of taught it. So usually all 4 of those have their own sets of plans as well, if you have all of the systems. So plumbing symbols are important to understand. Looking for the legend, also understanding that a lot of plumbing and mechanical legends are either the same or very similar. So you have to note what we're dealing with. Also important to note that hot water and heating hot water are different systems, or hot water heating I've seen too, HWH. So those are different systems. One's plumbing, one's mechanical, or one's HVAC, however you want to call it. Same thing with cold water and chilled water, or cooling water, however they want to throw that out there. Some plans also use abbreviations to determine what type of system we have. Others use line types to delineate. So a couple examples that we're talking about here. So if we're looking at different lines on a set of plans, sometimes they're mentioned with abbreviations, like I just said. Sometimes they have different styles of lines, right? So these ones are indicating hashes for any kind of storm sewer. V's are across the board for any kind of vent. The hot and cold water and recirculating are all just straight solid lines because they're probably the same materials. So you have to know how they're going to be indicated on your plans. Again, a couple of examples of different valves you might see on projects too. So just getting used to the indexes, getting used to table of contents sheets, getting used to symbols on your different projects is important so you can understand how to bounce back and forth a little quicker. Also, really important to learn schedules. Schedules to me are one of the most important pieces of a set of plans when it comes to MEPs because this shows you all of the items that you're putting in new, all of their requirements. And then that helps you kind of guide a lot more of how you're actually going to coordinate them, most often with like electrical requirements and how they correlate with your specs. So a couple examples of different schedules you might see, right? So generally speaking, you're going to have these later on in your plan sets. So if for instance, this is like a P700, it might be, right, where you're starting to look at schedules or an M600 or 700, depending on your project layout. And then last but not least here for plumbing, I just threw the divisions and what you would generally see for the master spec. The master spec just provides where the general areas are, how they're generally broken down. Then it's up to the architect and the design teams, right? The engineers primarily to say, how am I actually going to designate within these spaces here? Okay, move on to mechanical. Very similar concept as plumbing, but we're generally dealing with two types of plans other than demolition, but we generally have some sort of forced air plans and generally some sort of hydronic plans where you have heating and cooling loops. So usually speaking, they're on different sets as well. Remember the same comment as plumbing, or they're very similar from one project to the next. Some of the symbols look very similar to other parts of their project. So like an architectural, for instance, an architectural drawing might have a lot of the same shapes and designations as you would see on like a mechanical drawing, but you have to know that on a mechanical drawing, that circle, for instance, might mean something different than the circle on an architectural. So understanding where you are is a big deal with knowing how to utilize symbols. Use that legend. Again, very important, and the coordination between plumbing and mechanical legends is important to note. We also usually have more specific symbols for ductwork and piping, whether it's single line or two lines. So we have a couple piping symbols here. This is where there's a lot of overlap between plumbing and mechanical all the time. Okay, ductwork, we would have, if we're doing single lines, this is kind of like a single line ductwork example, and this would be a double line piping symbol, right, and double line ductwork symbol. The reason why we don't always use double lines is because when you start getting into full sets of plans, you start seeing lines on top of lines on top of lines on top of lines, so it's really hard to just keep adding more lines to see what we have. So a lot of times we'll use a single line diagram for things, and then on enlarged plans or details or diagrams, we'll start throwing the double line piping on there. Okay, mechanical schedules, just like plumbing, I would say even more so. This is actually, when I get a new project, probably the first place I would look after I got a general lay of the land through the architecturals and see like, what's going where and how are things sort of laid out in the project. The next place I look is almost always my mechanical schedules to learn what pieces of equipment I have going in. That indicates how this job's going to have to sort of be run. So a lot of information. You can get a ton of information out of here. This is where you're going to spend probably most of your, I don't know, I guess this is where I spent a lot of my time when I was managing projects, was in the mechanical schedules and dealing with the coordination with those subs. A couple examples for, hot water heating coil or different types of pump schedules. So like a chilled water pump, showing identification. This is from a different NMU project, right? What system that those pumps are serving, what the location is of those pumps, what type of pump we're dealing with, all the way throughout, all the way to like electrical requirements and so on and so forth. Okay, cooling tower schedule, this is an example there if you want to take a look. Again, you guys have all that information, and then the master spec. So again, within these, it's up to the architect and engineer to kind of say, so if I have HVAC piping and pumps, that's a 2320 designation. Well, I'll say maybe this type of pump particular is going to fall under 21-01. And then this type of pump is going to fall under 23-07 or whatever they want to determine. So they have their own way of doing things. And then electrical specific requirements. Generally, again, we're talking about two different types of plans here. So power and lighting would be those. Power is anything dealing with like outlets, equipment, where all those items go, and then lighting is obviously for lighting. Also important to note, going back to the original conversation about plan sets and how they're created. So if this is an electrical plan, it might be like, say, electrical new work power plan might be my E200s. My lighting plan might be my E300s. So if I have a 5-story building, it'd be E201 through 205 would be my power, and then E301 through 305 would probably be my lighting or something along those lines. So again, symbols often look similar, so make sure you know what sets of plans you're dealing with. A lot of boxes, a lot of lines, a lot of circles and rectangles, and very similar looking symbols all throughout. Also important to note, a lot of the different CSI divisions might get lumped into your electrical, right? So communications, security, fire alarm, those kind of things, different low voltage applications might get lumped in within your electrical plan legends. So make sure you know what you're dealing with there. A couple different symbols to kind of just generically look through here. Also duplexes, what your receptacles look like, what your switches might be with like 3- and 4-way toggles generally have an S with a 3 or a 4 next to them. Dimmers generally have some sort of D, sometimes seen S with a D. So just know how your plans are set up. And then also, again, your electrical schedule is very important, just like everything else. Different examples I'll let you look through, but we might have light fixture schedules, right? Motor circuit sizing schedules for different motors, circuit sizing requirements for different circuits that we have, and there's just all the equipment that goes with that too. And a couple examples here looking at power plans. So we have within your power plans that have wiring devices and equipment and motors. So could look something like this where we have different receptacles all listed throughout. I can't quite read what that one says, but this is some sort of mechanical unit that we're connecting to. It looks like a fan coil unit, FCU, that would be indicated by what type of power is required for it. These keynotes would indicate what those receptacles might be for. So since we have 16 and 33 for all of them, they probably have a very specific designation for how they're getting hooked up. And then your lighting plans are important to note that they're separate, right? But they're going to show wiring and circuits for different types of lighting. So we have here, right, emergency lightings are generally anyone that has like this sort of half black and white diagonal through it. It's also important to note that those are always wired on their own emergency circuits. Okay, so you can see how the wiring diagram kind of connects those, but then you have the rest of the circuits are connected along different or connecting different lights. Also important to note that when you're looking at lighting plans, it's often an issue where you have to review reflected ceiling plans as well, because you might have to look at grid pan or location of other items that might not be MEPs, right? So any kind of structural things that might be up there, or any kind of any other kind of architectural information that you could be gathering. So here's a reflected ceiling plan of that same area, just showing kind of how the grid's all laid out where anything else might be within the plans. And the last piece that's a little bit unique is the one-line diagram with the electrical. So the one-line diagram is basically a not to scale version of all of your circuits within your building, showing how everything is hooked up. It's basically a simplified notation of your entire power system. They get a little bit cumbersome. They're hard to read at first, but once you get the hang of it, you normally be able to get through them pretty quickly. So this is just an example of showing how a one line would work. So here we have a manhole where we're bringing the power into the building. We have some sort of switches that control right off the bat in our switch gear. So this is normally like our main switch gear. If you see these like sort of dashed lines going around here, just showing how the power comes into the switch gear and then how it gets distributed out of that switch gear. So different things like transformers is probably that designation right there, and fuses and So understanding the symbols, understanding what the different terminology means, what the different abbreviations mean, all throughout will help you understand how is the power getting distributed into my building and then throughout my building. This is just the example moving forward here. So these lines would get distributed here, and they go on to the next page where they're showing how, it gets distributed to different, lighting panels or some other type of panels that I don't, know what project this is. So I don't know what this designation is exactly, but we probably have some sort of supply and return fans down here that are getting controlled by this panel. So that's just, again, this is how your one line is sort of set up, just an extension of that. And then your CSI divisions for electrical, also through 25, 27, and 28, and as well for related sections. Okay, with that, I want to get into your assignment a little bit. So these different resources, so isometrics are a thing I didn't really go into at all, but isometrics are basically a 2D to 3D representation. So you take plan views and you have to interpret those based on plumbing symbols, which are shown here to learn how the 3D rendering might look for things like mechanical work, like plumbing and HVAC equipment and piping. Just a good visual representation, so so your trades know kind of how everything gets put together. We use them a lot for riser diagrams. So if you pull up this one, you'll see that this riser diagram examples is what we would consider isometric drawings, right? So on a plan view, we would just see things in straight east-west, north-south orientation, a flat 2D version. You have to interpret this based on symbols of how this is actually getting installed for these different diagrams. So good information there just to understand how to actually translate between them. There's a lot of different practice activities. If you want to do them, it's up to you. It's on your own time, not getting graded or anything. Different diagrams here, reading through duct drawings and everything. And then also more information on interpreting one-line diagrams. On to the assignment. So it is a 4-part assignment. This folder right here is shows you all of the plans. So the file is too big to throw in as both the plan and specs as their own individual documents, so I've broken them down into the different categories. So you will probably need most of them. You won't need probably the civil set, for instance, but you'll probably need title, mechanical, electrical, potentially telecom, right? Since we're dealing with MEPs. This set of plans did not break out plumbing separate from mechanical, so just make sure you understand that as well. Also broke out the CSI divisions too, so you might have to look through some of the front ends, so divisions 0, 0, and 0, 1, but then primarily into your 20s, because that's where we deal with our mechanicals and electricals. So these are the sets of plans you're going to have to get familiar with. The first piece of the assignment, I have to go through all this stuff again. The first piece of this assignment is just going through generic MEP plans and spec items. It's a little bit shorter, a little bit easier. It's designed to try to help you just get the lay of the land a little bit, understand how the plans are set up, get used to all the stuff I just talked about, and using that MEP plan spec reading PowerPoint as your resource. That'll help kind of lead you into the next one, into the next one, and the next one. So I have them, they're basically just one big assignment. It's the same exact thing. I just broke them down so they're a little bit easier. Maybe you can start one, you can, there's no time limit on any of them. So if, for instance, you start this one, you get through like 3 or 5 questions, and you're like, maybe I want to jump into mechanicals, I know them better. You can close that one out, get into the next one, and keep moving. They will close automatically on their due date, so pay attention to that, but you can open and close them as much as you want throughout. You don't have to do them all in one setting. Again, they're the same exact type of thing. You're just asking questions about different materials, different locations, all that kind of stuff to help navigate you through the set of plans and specs. And the CETF building is actually the building that we use. This is where we're housed at the university. So we're going through a pretty cool renovation right now and pretty excited about how it's going to look in the future. I think with that, that's pretty much everything I have on this assignment. I'll try to make the other ones short, but there's a lot of information here, and one of the big things to understand is when it comes to managing projects, you're not going to be an MEP contractor probably. I mean, if you're dealing with as a prime contractor or a construction management firm, you're going to have to coordinate a lot. So understanding how to read the language, which is heavily involving plans and specs, is kind of the main takeaway that you can probably get out of all this, because it's hard to coordinate unless you don't really understand or sorry, it's hard to coordinate if you don't understand how the plans and specs work for those different designations. And it was something that our advisory committee was heavily engaged in, that they want to see more plan and spec reading throughout the curriculum, especially in the MEP. So that's why we're kind of gearing our assignment work for this class heavily towards getting involved with plan and specs. So if you have any questions, please let me know.